Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Nitrogen inversion, pyramidal inversion. At the nitrogen atom of an aziridine passes through a planar, sp2 hybridized, transition state. The activation energy, delta G hash, for this inversion depends on the nature of the substituent on nitrogen. Moving on to the next step. General principle for nitrogen inversion in aziridines. In aziridines, 3-membered N-containing rings, nitrogen inversion is already significantly hindered compared to acyclic amines because ring angle strain opposes the sp2 transition state. The barrier is thus higher than in open-chain amines. Moving on to the next step. The delta G hash for inversion is lowest when the nitrogen substituent stabilizes the planar transition state, sp2, like nitrogen. Bulky alkyl groups generally raise the barrier because they introduce steric strain in the ground state but also affect the transition state geometry. However, a TBU group, being extremely bulky, actually lowers the barrier in aziridines because it destabilizes the pyramidal ground state more than the planar transition state, i.e., the ground state energy is raised by steric compression between TBU and the aziridine ring, making the transition state relatively more accessible, lower delta G hash relative to the destabilized ground state. And for the final step. A. NMe, NCH3 moderate barrier. Small alkyl group stabilize pyramidal ground state well. B. NNBU, similar to NMe but slightly larger, moderate barrier. C. NTBU, the very bulky TBU group creates significant steric strain in the pyramidal ground state of the aziridine, raising its energy. The planar transition state is less destabilized by the TBU group relative to the ground state, so delta G hash is lowest among alkyl substituents. D. NPH, the phenyl group can conjugate with the nitrogen lone pair in the planar transition state, but in aziridines the planar TS is still strained. pH actually raises the barrier because it prefers an lone pair delocalization into the ring, stabilizing the pyramidal form and raising the inversion barrier. The TBU group on nitrogen of aziridine destabilizes the pyramidal ground state most through 1,3 steric interactions with the ring CH2 groups, thereby lowering delta G hash for inversion the most. Therefore, the correct answer is C. Therefore, the correct answer is option C.